Okay. Everybody here on page 22? You don't want to be here, Haley?
Oh, no, I just don't like probabilities.
Oh, well, you may not like this lesson then. I wanted to start with some real basic probability. When do you guys do probability?
Like third.
I don't know.
Third grade, is that what you said?
Elementary school.
I don't think Ellie's hit it yet. She's in fourth grade. I haven't. Well, I guess.
It might be in middle school.
I know she's done just like a slight. No, I don't even know
It might
that.
be in sixth.
I don't know if I could even qualify that as
Why
probability.
don't you just teach her geometry now, and so that way she'll be ready for it. Good idea, right?
It is. It is. Okay, I wanted to start with some real basic probability. And we call this theoretical probability because we're not actually performing the experiment. If I was actually performing the experiment, then that would be different. But because I'm not performing it, it's called theoretical probability. And then after I do these, we're going to come back and we're going to do some geometrical probability, which is really the point of today's lesson. So the way I like to think of this is the probability of doing some event is getting what you want out of a total number of things that could happen. So that's like how I like to think of it. Getting what you want out of a total number of things that could possibly happen. So let's look at this first example. It says a bowl contains 12 slips of paper, each with a different name of a month. Find the theoretical probability that a slip selected at random from the bowl has a name of a month that starts with the letter J. Okay, so I'm going to take how many chances of getting what I want. So how many months start with the letter J? Three. Which ones are they?
July.
Okay, so January, June, and July. Okay, so I have 3 chances of getting what I want out of 12, because there's 12 total months, and it tells you that the bowl contains 12 slips of papers. Okay, and then I'm just going to reduce this fraction, and 3 over 12 reduces to 1 over 4. Okay, at this point, just because this fraction is so easy, I want to make sure everybody knows how to reduce a fraction in the calculator, just because in a little bit we'll have fractions that maybe aren't quite so pretty. Does everybody know how to make your calculator reduce a fraction? Okay, if I go 3 divided by 12 in the calculator like this and hit enter, I'm going to get a decimal. All I want to do is turn it back into a fraction. So I'm going to hit the button that says math and then enter. So I'm going to go math, and then enter because I want a fraction, and then enter because I'm ready to go. And then that will reduce the fraction for you. So if reducing a fraction is difficult, especially if it's a bigger fraction, then that's one way to do it. Just put the original problem in, hit enter, and then math, enter. Okay. The next one. It says, suppose you write the names of days of the week on identical pieces of paper. Find the theoretical probability of picking a piece of paper at random that has the name of a day that starts with the letter T. Okay, so I want the probability that I am going to draw the name of a day that starts with the letter T. So, how many chances do I have of getting what I want? 2, because why? Tuesday and Thursday. Those are the 2 that start with the T. So I have 2 chances of getting what I want out of 7, because there are 7 days of the week. And then does that reduce? No, so that's it. So right now I'm leaving my answers as fractions. In a little bit, I'll probably practice rounding to the hundredths a little bit. So it really doesn't matter, but right now I'm just leaving them as fractions. Okay, let's try this spinner. So it says a spinner with the numbers 1 through 12 is spun. Find each probability. Okay, first one, probability of spinning a 7. What do you think?
1 out of 12.
1 out of 12. I have 1 7, so I have 1 chance of getting what I want out of 12 total possibilities. Good. Okay, what do you think about a probability of getting a 5 or a 6?
2 out of 12.
2 out of 12. Because you have
1 over 6.
yes, because you have 1 chance of getting a 5, 1 chance of getting a 6. The word or means add, so 2 chances out of 12. And then yes, that does make 1 out of 6. Okay, what's your probability of getting an odd number?
6.
6 out of 12, which would reduce to so I have a 50% chance of spinning an odd number. Okay, what about the probability of spinning a 13? 0. There's not a 13. There's no way it can happen. So that is not something you'd want to bet on. Okay, number 5. Probability of getting a multiple of 3.
4 out of 12, right?
Which ones are your multiples of 3?
3, 6, 9,
12.
3, 6, 9, 12. So 4 chances out of 12, which makes 1 over 3. Okay. Okay, I want you to try A, B, and C on the bottom, and then we'll go through those. And then we'll get into the theoretical, the geometrical probability. I know, it makes you hungry, right?
You should do it with like real animal crackers.
I actually have some. Not enough for everybody, though.
Each person gets one animal cracker.
I might have enough for that. I don't know. I haven't checked my supply in a while. Do we have him? Ricky, where is your packet? Ricky, it's students like you that make me wonder why I do this sometimes. Why I do what I do. Teach. Haley, what'd you get for 8?
For A, I got 5 out of 14.
5 out of 14. Because there's 5 total hippos, so you have 5 chances of getting what you want out of 14 total crackers. Everybody okay with that?
Yeah.
Okay, Sierra, what'd you get for B?
Hang on. I flipped to homework. 5 over 7.
What did you start with before you...
10 over 14.
Yeah. So you have 10 animals that are not an elephant out of the 14 total elephants, and then if you reduce that fraction, you do get 5 out of 7. So good. And then, Judd, how about C?
3 over 7.
And before you got your 3 over 7, what'd you have?
6 over 14.
6 out of 14. Because there's 4 elephants and there's 2 lions, so or means add, so you had 6 chances of getting an elephant or a lion out of the 14, and then yes, that reduces to 3 over 7. Okay, so that's theoretical probability. I just wanted to practice that before we got into the geometrical probability. So it's getting what you want out of a total. Basically, that's what I wanted to practice, getting what you want out of a total. Okay, let's flip to the next page, and I want to start with the bottom. So starting with this section down here, it says, find the probability that a point chosen randomly inside the rectangle is in each shape. Round to the nearest hundredth. Okay, so these want me to actually round to the nearest hundredth, so I'm not going to leave them as a fraction. So what this is basically saying is, if I was throwing a dart, what's the probability of my dart landing in the triangle? So that's what it's really saying. So my dart could land anywhere in here. And we're going to pretend that the dart won't go outside of this shape. Yeah, so before with theoretical probability, basically I just wanted to practice it to get the idea of what you want out of a total. So what I want right now is getting in that triangle. So I want my dart to land in this triangle. And then my chances of that happening would be out of the possibility of it getting anywhere else inside this rectangle. So I'm going to find the probability by finding the area of the triangle. Does it make sense, area? Because my dart could land anywhere inside this shape, so that's why it's area. So probability of getting what I want, which is my dart to land inside the triangle, so I'm going to find the area of the triangle, out of the dart going somewhere else, which would be the area of the whole thing. And the whole thing happens to be that giant rectangle there. Okay, let's just find the area of this whole big rectangle for a second. How do you find area of a rectangle?
Length times width.
Length times width. So I would multiply my 48 times my 24. And what do we get if we multiply our 48 and our 24? Okay, so 1,152. So that's the area of the total rectangle. Okay, so that's going to be the denominator. And now I want to find the area of the triangle. So what's your formula for area of a triangle again? 1/2 base times height. Do you know the base of the triangle? 10. And how about the height? 10. Yep. So this right here is your base, and it's 10. This right here is your height, and it's 10. So it's 1/2 of 10 times 10. And what is 1/2 of 10 times 10? 50. Okay. So because this says round to the nearest hundredths, I'm just going to put it in the calculator like that. I don't even care that it reduces, because it does reduce. I'm just going to hit enter and round to the nearest hundredths. And what would you say? 0.04. So my probability of my dart landing in the triangle is 0.04. That means I have a 4% chance of my dart landing in that triangle. And of course, that doesn't mean that this picture is drawn to scale, but that's what it would be with all of the information in there. So it's like what we did before as far as probability of getting what we want out of a total. It's just I'm having to calculate area. Okay, so this time I want my dart to land in the square. So I'm going to find the probability of the dart getting in the square out of the probability of it going anywhere in here. Okay, so the probability will be getting the dart to go in the square. So I'm going to find the area of the square out of the possibility of the dart going inside that whole giant rectangle. So the area of the whole thing. Okay, how do you find area of a square? Length times width, base times height. So what would it be? 100. Your length is 10, your width is 10, and 10 times 10 does make 100. So the probability of my dart landing in the square is 100 out of, what was the total area again for the whole shape? 1152. Once again, I'm not even going to bother trying to reduce that down because it says round to the nearest hundredths. So I'm just going to put 100 divided by 1152 in. And if I round to the hundredths, what would you say? 0.09. The hundredths place is 2 places to the right of the decimal. So I go 2 places to the right. Once I get to that 8, I look to the right of it. If it's a 5 or higher, you round the 8 up. If it's a 4 or less, you keep the 8 the same. So it's 0.09. So this means I have about a 9% chance of my dart landing in that square. Okay, so it's kind of like before, still getting what we want out of a total. I'm just calculating area. That's all. Okay, we're going to move up to this next section that's above it. This time, I'm going to use a spinner. Think of it as a dart again. This time, I want my dart to land in the red section. So my dart could land anywhere in here. That's what I want. Or it could land anywhere in the entire circle. So I'm going to find the probability of it landing in the red by finding the area of this red sector out of the area of the whole circle. So this visits back what we've been doing the last few days. So the probability is going to be finding the area of the red out of the area of the whole circle. Let's just start with the whole circle because that's the easiest. How do you find area of a circle? Pi r squared. And what does it say the radius of the circle is? 6. So pi times 6 squared. And what's 6 squared? 36 pi. Okay, so that's the area of the whole circle. I've got the denominator figured out. Now I need to find the area of the red section. So to find the area of this sector, that's when we set up a proportion. So I'm just going to kind of do it off to the side over here. And then I'll come back and work back over here. Okay, so that's when we take how many degrees the arc is. So how many degrees is that arc? 80 out of the 360 in the whole circle. I'm interested in this red's area, that's Mr. X, out of the area of the whole circle. And would we find the area of the whole circle to be? 36 pi. Okay, go ahead and take a second, cross multiply and divide, and tell me what you get right there for your X. 8 pi? Is that what you guys got? Does anybody need to see me do it? Okay, now I have everything I need. So the probability of my dart landing in the red section is an area of 8 pi out of the area of the whole circle. And what did we say the area of the whole circle was? 36 pi. You remember how anything divided by itself is 1? So pi divided by itself, pi divided by pi is 1. They just cancel out. And that's my answer. I'm going to write it a couple ways. First, let's just reduce it. So I'm going to practice in my calculator, making my calculator reduce. Do you remember what I said to do? Math, enter. Of course, you could always make your brain do it, and you get 2 over 9. So if I want the fraction reduced, it'd be 2 over 9. And if I want to the hundredths, what would you say to the hundredths? 0.22. So I'm just going to write 2 different answers just because you never know what might be asked of you. So we have about a 22% chance of our dart landing in this red section out of the whole circle. Okay, let's try number 2. Number 2 wants the probability that the pointer lands on purple or blue. And I like the dart thing. So I want my dart to land in the purple section or the blue section. Do you remember what I kept saying about the word or earlier? I said it a couple times. It means to add. So I'm going to add the purple to the blue. And it doesn't matter that they're next to each other. They could have been here and here. I could still add them. So I'm going to do the same thing. I'm going to find the area of the purple and the blue together out of the whole. So I'm going to find the area of the purple or blue out of the area of the whole. But I don't have to do 2 separate proportions. I could just do 1 proportion by just adding the 2 together. So that's what I wanted to do here. So if I'm interested in the purple and the blue, what do you get if you add their 2 arcs together?
135.
So 135 out of the 360 in the whole circle. I want to know the area of them both, so that's the x, out of the area of the whole kit and caboodle, which would be?
Oh, what?
36 pi. Kit and caboodle.
I've already done
If you don't say it, you should. People will be like, oh, you're cool, Mason. Okay, anybody have that one? 13.5? Okay, and then don't forget to put your pi back behind it. So that's the probability of, that's the area of the purple and blue section together. Okay, so that's what I want right here, the area of the purple or blue. So that was my 13.5 pi divided by the area of the whole thing. And what's the whole things again? 36 pi. And then anything divided by itself is 1, so the pi's can cancel out. Let's just see if this will reduce. So 13.5 divided by 36. If I go math, enter, I get 3/8. So there's my reduced fraction. And what would you say to the nearest hundredths? 0.38. Okay, so 3/8 is the reduced fraction, and 0.38 is to the hundredths. So we have about a 38% chance of that happening. You feel like you understand how to do this? Uh-huh.
On both of them, I just added the degrees together.
And divided by 360?
Yeah, and it's doing the same thing.
Yes. I know. With these, and I was wondering if anybody would notice, but the reason I'm doing it the way I'm doing it is because down here I had no other way of doing it than finding the area of my dart landing in the triangle out of the area of my dart landing in this whole rectangle. So I thought I would keep my teaching consistent, where I was finding the area of this red out of the area of the whole. So I don't know if everybody heard what she was saying, but what she said was she added these 2 together, 135, and took the 135 out of the 360 and got the 0.38 that way. And like up here when I did the red, if you just took how many degrees it is, 80, out of how many degrees in the full circle, you do get the same answer. But the next problem I'm about to do, we have to do area with that as well, and we had to do area with this as well. And so I didn't want to go area and then all of a sudden not do area, because I just thought that would be really confusing to you. So it does actually work on this one to just take how many degrees the arc is out of the 360 in the circle. It will work, but that would not work on these down here, and I'm about to do a dartboard problem, and it's not going to work on that either. So that's one reason why I was trying to teach it like this, where you find the area of what you're interested in out of the area of the whole thing. Okay? So if you know that you can do that on these, then I'm perfectly fine with that. I was just trying to keep my teaching consistent so you guys want to get confused. Okay, not trying to trick you, just trying to keep it consistent. Because I hate it when you know there's a rule for this and there's a rule for this and there's a rule for that, and then everybody gets confused. So I just thought if we had the one same rule and we just kept doing it the whole way through, it would be all good. Okay, Students a lot of times do not like these dartboard problems, so this one is all worked out for us. I'm just going to talk you through it. So basically, we're on the dartboard kick or throwing dart kick. I want the probability of me getting at least 10 points. So I'm just going to kind of talk through what they are showing you here. What does it mean if you want to get at least 10 points?
You want, oh, you throws that out of the lowest would be 10.
10 and
You
20.
want both of them.
10 and 20, right? So I could get 10 or I could get more than that. So I want to get at least 10 points. So if I want to get at least 10 points, I want my dart to either land in the 10 section or in the 20 section. I don't want it in the 2 or the 5 section. Okay, so at least 10 points means I want to get it in the 10 or the 20 section. So I don't want to color on my dartboard too much because I'm going to use it for these next problems, but I want to get right in here. I want to get in the 10 and the 20 circle. So I'm going to find the area of that out of the area of the whole, which is what I was doing on the previous page. So just to talk about that again, you don't have to flip back. But here, when I was trying to get my dart in the triangle, I was finding the area of the triangle out of the area of the hole. And up here, when I wanted my dart to land in the red section, I was finding the area of the red out of the area of the hole. And so this is the same thing. This time I want to score at least 10 points, so I want my dart to land in one of these two circles, so I'm going to find the area of this out of the area of the hole. And then it does tell you that the radius is 2, and it does tell us that the width of each ring is 2. So from here to here is how far? 4. So that's why you see pi times 4 squared, because that's the area of getting where we want our dart to go, which has a radius of 4, out of the area of the whole thing. And the radius of the whole thing is how much? 8. And that's why you see pi times 8 squared there. And then they just worked it out and got an answer. Okay, so let's try this first one. This first one's easy. I want to score 20 points. So where do I want my dart to go? Just right here in the center. So I'm going to find the probability that my dart's going to go here by finding the area of the 20 circle out of the area of the hole. So that's my goal. Okay, so let me write that down. So the probability is going to be the area of the 20 out of the area of the hole. Okay, how would I find the area of the 20 circle? It's a circle, so it's going to be pi times radius squared. And do we know the radius of the 20 circle? The radius is 2, so it's going to be pi times radius squared, so pi times 2 squared. And I'll take care of that in a second. Out of the area of the whole circle. And what's the radius of the whole circle again? 8. Because it says the width of each ring is 2, and that this radius is 2, so 2, 2, 2, 2 is 8. So pi times 8 squared. And then let's just work that out. So how much is 2 squared? So I get 4 pi over, how much is 8 squared? 64, so 64 pi. Like earlier, anything divided by itself is 1, so the pi's can cancel out. And then all I'm going to do is reduce my 4 over 64.
1/16.
And you get 1/16. Okay, this time I'm just going to write it as a fraction. If I wanted a decimal, we all know how to do that. But let's just write it as a reduced fraction. So I have 1 out of 16 chance of my dart landing in the 20. Okay, this next one, not so easy. This one I want to score 5 points. So where do I want my dart to go? I just want to score 5 points, not 5 or more. Yeah, this one was at least 10 points, so that was 10 or more, the 10 or the 20. This one, I just want to score 5. So I only want my dart to land in this 5 ring. Does anybody have any idea how I could find the area of the 5 ring?
No.
You switch the denominator and denominator, right?
Get the area and subtract the area.
Yes, I think this is what you're saying. So I think Mason is telling me to find the area of all this. Is this what you were saying? And subtract what?
Subtract the area of the 10 and the 20.
And subtract the area of the 10 and the 20. Does that make sense? If I found the area of all of this, that's way too much area, right? So then I would find the area of these two, and I would subtract it. And would that give me just this 5 ring? So that's what I'm going to do. So the probability of getting in this 5 is going to be the area of this out of the area of the whole. It's just in order to find the area of just getting in the 5 ring, I'm going to take the area of this whole thing that I drew in red here and then subtract the 2 centers. Okay, so let's just work on that. So let's go pi times radius squared minus pi times radius squared, because I'm working with 2 sets of circles. Okay, so for this big one here, what's the radius of it? 2, 4, 6, okay? And then we're going to subtract the 2 inside ones, and what's the radius of the 2 inside ones? 4. 2, 4. Okay, so how much is 6 squared? So I've got 36 pi minus, how much is 4 squared? So minus 16 pi. And what's 36 pi minus 16 pi? 20 pi. Okay, so that is the area of getting just in the 5 ring out of the area of the whole thing. And we already know the area of the whole thing because we worked it out a minute ago. What's the area of the whole dartboard? 64 pi. Okay, and then the pies can cancel out. Anything divided by itself is 1, so shoop goes the pies. And then can somebody reduce the 20 over 64 for me? 5 out of 16. Okay, I'm not going to do the next one, but I want to talk about it. If I wanted my dart to just land in the outer ring, so just in the 2 ring, what would I have to do? Same thing. I'd find the area of all of it. And we already know that. What's the area of all of it? 64 pi, right? And I would have to subtract the what? The 5, the 10, and the 20 rings. And that had a radius of how much? The 5, the 10, and the 20 rings. 2, 4, 6. It had a radius of 6. So that would have been 36 pi. So that's how you would do that one. Okay, let's try this one just because it hasn't been drawn on. And then I'm going to let you guys work. Okay, this says on the dartboard, the center circle has a diameter of 2 inches. Okay, so this center circle here, it has a diameter of 2. I'm only interested in the radius because area of a circle is pi times radius squared. So what would the radius be?
1.
Okay. Then it says, what's the probability of hitting the shaded ring? So all I want to do is have my dart hit the shaded ring. So I'm going to need to find the area of the shaded ring out of the area of the whole thing, because that's how we do probability. So probability is area of the shaded ring out of the area of the whole thing. How can I get the shaded ring? Same thing that we did up there. Do you guys think you could do it yourself? Okay, so if I found the area of all of this, do you agree that that's too much? Because I just want the shaded piece. But let's start there. Let's find just the area of that. So the area of that would be pi times radius squared. And what is the radius of all of that? 6, because it's 1 plus the 5. Okay, and then you said that's too much, so I'm going to subtract what's not shaded. And the inner circle is the one that's not shaded, and what's its radius?
1.
So pi times 1 squared. Okay, let's just go ahead and clean that up. How much is 6 squared? So 36 pi. And then how much is 1 squared? So minus 1 pi. What's 36 pi minus 1 pi? 35 pi. Okay, that is the area of getting the shaded ring. And then I have to divide that by the area of the whole thing. So to find the area of the whole thing, I need to know the radius of the entire dartboard. And what would the radius of the entire dartboard be? 11. So pi times 11 squared. Take a second and see if you can clean that up and give me a reduced fraction. What do you guys get?
35 over 120.
Yeah, 35 over 121. So you have the 35 pi on top. 11 squared is 121, so 121 pi. Anything divided by itself is 1, so shoop, the pi's cancel, and then you can't reduce the 35 over 121. So there it is as a reduced fraction. If I followed the directions and rounded to the nearest hundredths, then it would be, what if you rounded to the nearest hundredths? 0.29. And that's if I read the directions. So that would be about a 30% chance of my dart landing in the shaded section. So a lot of students kind of struggle with these dartboards. Do you feel like you kind of understand? So that's one reason why I taught this section right here the way I did. I just was trying to keep it consistent by finding the area of what I want out of the area of the whole, area of what I want out of the area of the whole, because that's how all of these were. Area of what I want out of the area of the whole. Okay, so what I'm assigning you, and I'm going to let you guys have the last 13 minutes to work on it. So on page 25, I guess I'll start with this one. So on page 25, I'm going to have you do 13, 15, 16, and 18 through 20. So 13, 15, 16, 18 through 20. So this is the assignment that goes over what I just taught. And I'm skipping a whole bunch just to make it more reasonable so you guys don't spend so much time. So 13, 15, 16, 18 through 20. So the 18 through 20 are dartboard problems. Yay for that. And then on page 29, this is the review. So on page 29, I want you to try another dartboard problem. That's like the one that we just did. So I want you to try number 26 on page 29. So it's a dartboard problem like we just did, and there is a dartboard problem on the test that's similar to this. So that's one reason why I wanted to make sure that you kind of understood those. So if you want to start with 26, you could, and then you could backtrack to page 25 or whatever. But you guys have about 10, 13 minutes to see what you can get done, and then I can try to help